Assalamualaikum and hi everyone, welcome to our group discussion video. Today we are presenting about common acid used in industry. Our group members are Naadhiroh Binti MH Mohammed Sharif, Nurin Amanina Binti Zuraidi, Amalin Safiah Binti Radzi, and Faiqah Auni Binti Hasamuddin. First of all, let's go to the next slide, which is introduction about this topic. First of all, let me introduce a bit about acid properties. Acid usually have sour taste, for example, lemon. pH of acid is from 1 to 6. Acid will change blue litmus paper to red. Acid react with metal will produce hydrogen gas. For example, acid is HCl and metal is zinc will produce zinc chloride and hydrogen gas. Acid react with carbonate or bicarbonate salt will produce carbon dioxide. For example, HCl as an acid and calcium carbonate as a carbonate salt will produce calcium chloride, carbon dioxide gas, and H2O, which is water. Acid react with base will produce salt and water. For example, HCl as an acid, sodium hydroxide as a base will produce sodium chloride and water. Next slide is about definition of acid. Definition of acid based on three, which is Arrhenius, Bronsted-Lowry, and Lewis. Okay, Arrhenius acid mean is a substance that forms hydrogen ions H+ when dissolved in water or dissociates in water. For example, HCl will dissociate into H+ and Cl-. It's also called monoprotic acid because contains only one H+ ion. Another example is H2SO4 dissociate in water will produce 2H+ plus SO4 2-, also called as diprotic acid because when dissociate in water will produce 2 hydrogen ion. Definition of acid based on Bronsted-Lowry. Acid is a proton donor or also called as hydrogen ion donor. In example, we have H2O react with NH3. H2O as an acid and H3 is as a base will produce OH- and NH4+. Okay. H2O will lose one hydrogen ion and will become OH- and also called as conjugate base. NH3 will gain one hydrogen ion will produce NH4+ and also called as conjugate acid. Last definition of acid is a Lewis. Lewis acid is a species that accept an electron pair or electrophile. For example, H2O react with NH3 will produce NH4+ and OH-. Okay, H+ accept a lone pair of electron from nitrogen atom and will produce NH4+. So H+ is an electron pair acceptor, also called as electrophile. So H+ is a Lewis acid. There are two types of acid, which is strong acid and weak acid. Strong acid is an acid that ionizes completely in water. For example, HCl, H2SO4. Weak acid is acid that ionizes partially in water. For example, CH3COOH, which is acetic acid, formic acid, HCOOH, and phosphoric acid, H3PO4. Based on the slide, we can see strong acid. For example, HCl dissociate completely in water. HCl ionized completely into H+ and Cl-. But weak acid, for example, in this picture, which is CH3COOH, only one molecule that dissociate completely into H plus and CH3COO minus, but two other molecule does not dissociate and remain as a CH3COOH plus molecule.
Second, uses of acid. First is citric acid. Citric acid is a weak organic acid that occurs naturally in produce such as citrus fruit. Citric acid composition is C6H8 and O7. It's mainly used in cosmetic products as food preservatives and cleaning products. Next is hydrochloric acid. Hydrochloric acid is a solution of hydrogen chlorine in water. Hydrochloric acid composition is HCl, mainly used as food acidifier to enhance the flavor and reduce spoilage, also as steel pickling, and lastly as cleaning agent. Lastly, acetic acid is an organic compound with the formula of CH3COOH. It is a carboxylic acid consisting of methyl group that is attached to the carboxyl functional group. It's mainly used such as in medicine field as antiseptic, and secondly as vinegar, lastly as cleaning solution.
In this slide, I will explain about the importance of acid.
Firstly, acid can help innovation in products. For example, renewable energy and oil production. Sulfuric acid is used in the electrolyte solution for car batteries, enabling efficient energy storage. These batteries also offer long lifespans and high efficiency in solar power storage systems. For oil production, hydrochloric acid is used to create large pores in rocks, improving oil flow and helping extract oil. This aspect typically produces oil and gas more efficiency and can reduce extraction cost. Next, safety improvement in the workplace include critical safety measures in handling and proper storage practice. Awareness of risk ensure workers use appropriate personal protective equipment (PPE) such as acid-resistant gloves, goggles, and aprons. Understanding the properties of acid and knowing how acid are used in a process highlight unique dangers that can reduce risk on the job. For storage practice, proper tools like acid-resistant containers, pumps, and handling equipment minimize exposure. Additionally, training and protocols ensure workers are well informed about safe handling practice. Lastly, cost reduction can be achieved through efficient practice in metal purification and fertilizer production. Phosphoric acid works as an affordable and effective rust remover, able to minimize energy consumption compared to mechanical cleaning methods. Its effectiveness in one application also reduces labor and material costs. In agriculture, reliable fertilizers such as ammonium phosphate are essential for fertilizer production as they reduce operating time and ensure efficiency in large-scale processes.
The last part is general conclusion. In summary, we explain about theory of acid properties and its type. Acids are defined by their reactivity, pH, and proton donating capacity, and the difference between weak acid like acetic acid and strong acid like hydrochloric acid. Besides their theory, we also focus on industrial application of three common acids, which are citric acid, hydrochloric acid, and acetic acid. Citric acid is the one most important industrial chemical that help in cosmetic product and food preservative, and hydrochloric acid widely used in food acidifier and cleaning agent, and lastly acetic acid has been used as vinegar. Understanding the use of acid in industry also provides several key benefits. Firstly, it helps in industrial application and improve industrial development. Industry can reduce wastage and energy consumption by selecting the proper acid for cutting processes. And finally, acid also benefit in medical and biological use. In conclusion, acids are essential in many industrial applications as a chemical for development in manufacturing, food production, and the environment. Their unique properties enable efficient process like fertilization production, metal cleaning, and food preservative in daily life. By understanding acid application, industry can increase productivity and guarantee worker safety, and lastly reduce the environmental effect.
This is our reference for this topic. Thank you for watching our video.